Hi friends, now let us discuss about the efficiency of the screw jack. The efficiency of a s- screw jack. The efficiency of a screw jack, it will be defined as the ratio between the ideal effort, so that is the effort required to move the load, neglecting friction, to the actual effort, so that is the effort required to move the load, taking friction into account. As we know that the effort required to lift the load, it will be the W when friction will be taken into account. So you can write it down as P equal to W tan of alpha plus phi. So this is when friction is taken into account. And alpha will be the helix angle and phi will be the angle of friction. And next mu will be the coefficient of friction between the screw and nut. Otherwise it can be given as tan phi. So if there would have been no friction between the screw and the nut, then phi will be equal to 0. Then the value of the effort P naught necessary to raise the load will be given as, so when phi will be equal to 0, then P naught, you can give it as W tan of alpha plus 0. So that is W tan alpha. So now, therefore, efficiency efficiency will be equal to ideal effort by actual effort. So that will be P naught by P, W tan alpha by W tan of alpha plus phi. So you can cancel that. So that will be given as tan alpha by tan of alpha plus phi, which shows that the efficiency of a screw jack, which is independent of the load raised. So independent of the load raised. The above expression, so for efficiency, only the screw friction is considered. However, the screw friction and the collar friction also will be there. So you are going to take the collar friction also into account. Then efficiency will be equal to torque required to move load, neglecting friction, to the torque required to move load, including screw and collar friction. So then you can write it down as, that will be the T naught by T, P naught into D by 2 by P into D by 2 plus mu into W into R. So in the mu, you can write it down as mu1. Here the efficiency of the screw jack may be also considered as the ratio of the mechanical advantage to the velocity ratio. So we know that uh, the efficiency of the screw jack. Efficiency are also considered as the ratio of mechanical advantage to the velocity ratio. So as the mechanical advantage, you can write it down as W by P1. So from this, W by P1, you can write it down as P into D by 2L. So 2L is going to in the numerator. So then you can write it down as W into 2L by W tan alpha plus phi into D. So you can write it, W will get cancelled. 2L by tan of alpha plus phi into D. So we will write it down. And the velocity ratio you can give it as distance moved by the effort P1 in one revolution to the distance moved by the load W in one revolution. Okay, so distance moved of the load P1 in one revolution, you can give it as 2 pi into L. So that is the length of the next, the distance moved. So it is given by the P. So we know that 2 pi L by P means tan alpha into pi D equal to 2L by tan alpha into D. So here the efficiency, you can write it down as efficiency equal to mechanical advantage by velocity ratio 2L by tan of alpha plus phi into D into velocity ratio tan alpha into D by 2L. 2L will get cancelled and also D will get cancelled. Then you can write it down as tan alpha by tan of alpha plus phi. So like this also you can. And now the maximum efficiency of the screw jack. Maximum efficiency of screw jack. So as we had solved that efficiency equal to tan alpha by tan of alpha plus phi. This you can write it down as sin alpha by cos alpha by sin of alpha plus phi by cos of alpha plus phi. So from this, you will get sin alpha into cos alpha plus phi by cos alpha into sin of alpha plus phi. So now we are multiplying the numerator and denominator by 2. Then you can 2 sine of alpha into cos of alpha plus phi by 2 cos alpha into sine of alpha plus phi. So you can write it down as sine of, as we know that 2 sine A cos B will be equal to sine of A plus B plus sine of A minus B, and 2 cos A sine B will be written as sine of A plus B minus sine of A minus B. So from this we are going to write sine of 2 alpha plus phi minus sine phi by sine of 2 alpha plus phi plus sine phi. So here the efficiency will be given by this equation. Okay. The efficiency of this equation is going to be maximum when sine of 2 alpha plus phi will be maximum. That is, when it will be maximum when sine of 2 alpha plus phi will be equal to 1 and 2 alpha plus phi will be equal to 90 degrees. Here 2 alpha will be equal to 90 minus 5, and the degrees minus 5, or you can write it down as alpha will be equal to 45 minus 5 by 2. And now substituting this, the value of 2 alpha in this equation, then you will have the maximum efficiency. Maximum will be equal to sine of 90 minus 1 plus 1 minus sine phi by sine of 90 minus 1 plus 5 plus sine phi. So here phi is going to get 5 going to be 0. Then sine 90 will be 1. 1 minus sine phi by 1 plus sine phi. Maximum efficiency, you can write it as 1 minus sine phi by 1 plus sine phi. Now let us discuss about the overhauling of screws and self-locking screws. When the angle of friction phi, if it is less than the helix angle, that is alpha, then the torque required to lower the load will be negative. So then the load will start moving downwards without the application of any torque. Such a condition is known as the overhauling of the screws. If the angle of friction is greater than the helix angle, then the torque required to lower the load will be positive, indicating that an effort is applied to lower the load. Such a screw is known as the self-locking screw. In other words, if you say a screw will be self-locking if the friction angle is greater than the helix angle, or coefficient of friction is greater than the tangent of helix angle. So from this, overhauling and self-locking screws. So from that article, we know that P equal to W tan of phi minus alpha. So this is the load, and torque required to lower the load will be given as T equal to P into D by 2, as we had discussed in earlier video. That is W tan of phi minus alpha into D by 2. So when, for this expression, if phi is less than alpha, then the torque will be, for lowering the load, will be negative. Negative. So in other words, whatever the load is there, so the load is going to start moving downward without any application of force. Okay, and that condition is called overhauling of screws. And in the same way, if phi is greater than alpha, then torque will be positive. Then the torque required to lower the load, so that is the positive. So here you need the effort to lower this load. That is, the effort should be needed or applied to lower the load. Okay, so that condition is called the self-locking screw. Okay, and next, efficiency of the self-locking screws. We know that efficiency of the screw, that is tan alpha by tan of alpha plus phi. So for self-locking screws, as we have discussed, phi is greater than or equal to alpha, or alpha is less than or equal to phi. Therefore, the efficiency of self-locking screws will be less than or equal to tan phi by tan of phi plus phi. So again, that will be less than or equal to tan phi by tan 2 phi. So that is less than or equal to tan phi. So a tan 2 phi will be equal to 2 tan phi by. So we know that tan 2 phi equal to 2 tan phi by 1 minus tan square phi. Okay. So we are going to substitute in place of 2 phi this equation. Tan phi into 1 minus tan square phi by 2 tan phi. So that will be less than or equal to. So tan phi by 2 tan phi minus tan square phi by. So you can see here tan square phi by 2 tan phi. Can't keep facility. So that is less than or equal to. So tan will get cancelled. So 1 by 2 minus. So tan phi and 1 tan, and this will get cancelled. That is tan square phi by 2. So from this expression, we see that efficiency of self-locking screws will be less than half, will be less than half, so that is 50%. If the efficiency of the screw is more than 50%, then the screw is overhauling. That is, without any application of force, the load is going to get lowered. If it is less than 50%, then it is a self-locking screw. Okay. Then again, it will also be proved by this method. So first, let W equal to load to be lifted and H equal to distance through which load is lifted. So then the output will be the W into H. So that is work lost in overcoming friction will be equal to input minus output. So we know that the input will be W into H bar efficiency minus W into H. So you can take it out, W into H as common, 1 by or minus 1. So for self-locking screw, for self-locking screw, W into H, the 1 minus efficiency minus 1 should be less than or equal to W into H. So that is 1 by efficiency minus 1 is less than or equal to 1. Then efficiency will be less than or equal to 1 by 2. Equal to 2 and efficiency equal to 1 by 2. So that is half or 50%. So by this method also you can solve it.